What if I told you that right now, as you watch this video, a human-made object is about to become the third in history to pierce the boundary between our solar system and true interstellar space? New Horizons, traveling at 36,373 miles per hour, is on the verge of making a discovery that NASA scientists believe could rewrite our understanding of the cosmos. In just 267 days, it will reach a region where the laws of physics as we understand them begin to break down. And what it's already detecting has left astronomers speechless. The data New Horizons is sending back defies everything we thought we knew about the edge of our solar system. The boundary between our sun's influence and interstellar space, called the Heliopause, should be a relatively smooth, predictable transition. Instead, New Horizons is detecting what scientists are calling impossible structures, massive waves and distortions in the heliopause that are 42% larger than any model predicted possible. It's as if we expected to find a calm beach where the ocean meets the shore, but instead discovered tsunami-sized waves frozen in place. The cosmic ray readings show fluctuations 300 times more intense than anything Voyager 1 or 2 detected during their crossings. The magnetic field structures show patterns that Dr. Elena Rodriguez at NASA describes as physically impossible under our current understanding of heliophysics. Most baffling of all, New Horizons has detected what appears to be a massive tunnel of lower-density interstellar medium penetrating deep into our heliosphere, like a river cutting through solid ground. How could we have been so wrong about something so fundamental to our cosmic neighborhood? To understand why these discoveries are so mind-bending, we need to understand what we thought we knew about our solar system's boundary. Our sun constantly emits a stream of charged particles called the solar wind, traveling at roughly 400 kilometers per second. This creates a protective bubble around our solar system called the heliosphere. The heliosphere has several distinct regions. First is the termination shock, where the solar wind abruptly slows down. Beyond that is the heliosheath, a turbulent region where the solar wind is compressed and chaotic. Finally, there's the heliopause, the actual boundary between our solar system and interstellar space. We've only had direct measurements of this boundary twice before. Voyager 1 crossed the heliopause in 2012, followed by Voyager 2 in 2018. Their data suggested a relatively predictable boundary, with some expected variations based on the sun's 11-year activity cycle. Computer models created from this data showed a roughly symmetrical bubble with a slight compression on the leading edge due to our solar system's motion through the galaxy. New Horizons was never originally intended to study the heliosphere boundary. Launched in 2006, its primary mission was to study Pluto and the Kuiper belt. After its stunning flyby of Pluto in 2015 and the object Arrokoth in 2019, scientists realized its trajectory would take it through interesting regions of the outer solar system. In 2024, NASA approved the extended Heliosphere mission, equipping New Horizons with new software to maximize its remaining power for heliosphere studies. The spacecraft began dedicated observations of the outer heliosphere in early 2025. This is where things get strange. Based on the Voyager missions, scientists expected New Horizons to detect a gradual decrease in solar particles and a gradual increase in galactic cosmic rays as it approached the heliopause. The boundary crossing should be relatively smooth and predictable. But what New Horizons is actually detecting is something entirely different, and it's forcing us to completely rethink our understanding of how our solar system interacts with the rest of the galaxy. What I'm about to reveal next is the most shocking part of this scientific mystery, the actual data that's causing astronomers to question everything we thought we knew about our cosmic neighborhood. If you're fascinated by how the universe continues to surprise us, this is exactly why I make these videos. Hit subscribe and enable notifications so you never miss these cosmic revelations as they happen. Trust me, what comes next will change how you think about our place in the galaxy. The story of this discovery begins in January 2025, when New Horizons' newly upgraded SWAP instrument, Solar Wind around Pluto, detected the first anomalies. Dr. Elena Rodriguez, lead heliophysicist on the mission, initially thought there was an instrument error. The readings showed plasma densities fluctuating by factors of 20 to 30 within relatively short distances, something that should be impossible in the outer heliosheath. By March 2025, after weeks of verification, the team confirmed the instruments were working correctly. The data was real. The team immediately requested additional observation time from NASA's Deep Space Network to increase data transmission rates. In April 2025, the spacecraft's dust counter registered another anomaly. Interstellar dust concentrations varied dramatically along New Horizons' path, forming what appeared to be dust lanes, with densities up to 80 times higher than surrounding areas. Dr. James Chen at Johns Hopkins Applied Physics Laboratory described it as finding highways in what should be an empty desert. The real breakthrough came in July 2025, when New Horizons detected what scientists are now calling heliospheric ripples, massive wave-like structures in the boundary region that shouldn't exist according to any current model. These ripples extend for millions of kilometers and appear to oscillate with unexpected regularity. By September 2025, the mission team had collected enough data to create preliminary 3D models of these structures. What they found left them stunned. The heliopause wasn't just slightly irregular, it contained massive protrusions and indentations, some extending billions of kilometers from where they should be. The most dramatic discovery came in January 2026, when New Horizons detected what appears to be a massive tunnel of lower-density interstellar medium penetrating deep into the heliosphere, almost like a river cutting through a landscape. This structure extends at least 7 billion kilometers and shows no signs of dissipating. With each new transmission, the mystery only deepened. What could possibly cause such dramatic distortions in what should be a relatively uniform boundary? And what will New Horizons discover when it actually crosses this bizarre, distorted heliopause in the coming months? After months of analysis, scientists have developed three main theories to explain these bizarre findings, each with profound implications for our understanding of the cosmos. The first and currently most supported theory involves previously unknown properties of the local interstellar cloud, the specific region of interstellar space our solar system is currently traveling through. Dr. Sarah Jameson at the European Space Agency explains, "We now believe the local interstellar cloud contains filamentary structures, essentially cosmic weather systems that create these dramatic variations in density and magnetic field strength. These interstellar filaments appear to be remnants of ancient supernova explosions that occurred millions of years ago in our galactic neighborhood. As our solar system moves through these structures at 23 kilometers per second, they interact with our heliosphere in complex ways, creating the ripples and distortions New Horizons is detecting." To understand this, imagine sailing a boat through water that contains both strong currents and patches of seaweed. The boat's wake, our heliosphere, would be dramatically distorted by these obstacles, creating patterns that would be impossible to predict without knowing the exact distribution of these features. The second theory suggests something even more radical, that the interstellar medium itself may contain previously undetected forms of matter or energy that interact with our heliosphere in unexpected ways. Some researchers have suggested these could be related to the mysterious dark matter that makes up roughly 27% of our universe. Dr. Michael Chen at Caltech explains, if certain forms of dark matter concentrate in filaments or clouds, they could create gravitational effects that distort the interstellar medium, creating the patterns we're seeing. It's speculative, but it would explain the regularity of some of these structures. The third theory proposes that our Sun itself may have previously unknown cycles or behaviors that affect how the solar wind shapes our heliosphere. Dr. Rodriguez points to unusual solar activity patterns observed between 2020 to 2025. We've detected subtle variations in the solar wind that don't match any known solar cycle. These variations, amplified over billions of kilometers, could create the distortions we're seeing. What makes this discovery so significant is that it doesn't just change our understanding of our solar system, it potentially changes our understanding of every stellar system. If these interstellar structures are common throughout the galaxy, then the protective bubbles around other stars would be similarly distorted, with profound implications for the development of life on any planets they contain. As New Horizons approaches the actual crossing of the Heliopause in late 2026, scientists are preparing for what might be the most important data transmissions in the history of heliophysics. The spacecraft's unique trajectory will take it through regions never before explored, potentially revealing the true nature of these mysterious structures. Just when you thought you understood what was happening at the edge of our solar system, the story takes another dramatic turn. In March 2026, astronomers using the James Webb Space Telescope made a discovery that added another layer to this cosmic mystery. While studying nearby star systems, they detected similar distortion patterns in the astrospheres of 7 nearby stars, the stellar equivalent of our heliosphere. But here's the twist: these distortions appear to be aligned along a common axis across multiple star systems, spanning over 15 light-years. Dr. Hiroshi Tanaka at the National Astronomical Observatory of Japan explains the implications. Finding similar patterns across multiple star systems suggests we're dealing with a large-scale structure in the interstellar medium, something that extends far beyond our solar system. This discovery has led to a fourth, even more radical theory, that these distortions might be evidence of a previously unknown large-scale structure in our galactic neighborhood, possibly a remnant of an ancient hypernova explosion or even the wake of a massive object that passed through our region of the galaxy millions of years ago. Adding to the complexity, the New Horizons team announced in April 2026 that they had detected unusual variations in cosmic ray intensities that correlate with the heliosphere distortions. These variations show patterns that suggest the presence of localized magnetic field structures in interstellar space that shouldn't exist according to current models. Dr. Elena Rodriguez notes, "We're seeing cosmic ray shadowing effects that imply magnetic structures hundreds of times stronger than what we thought possible in the interstellar medium. It's as if there are magnetic storms out there that we never knew existed." Perhaps most intriguingly, some of these patterns appear to correlate with the mysterious cosmic ray hotspots detected by the Antarctic Impulsive Transient Antenna, ANITA, experiments between 2016 and 2024, suggesting a possible connection between phenomena observed at Earth and the structure of the distant heliosphere. The question now isn't just what's causing these distortions, but what they tell us about the larger structure of our galaxy and the forces that shape it. And as New Horizons prepares to cross this boundary, scientists are debating what it might encounter on the other side. I genuinely want to know what you think about these incredible discoveries. Which of these theories makes the most sense to you? Do you think we're seeing the effects of interstellar filaments, dark matter concentrations, unusual solar behavior, or evidence of some larger galactic structure? Or perhaps you have your own theory about what's causing these bizarre distortions at the edge of our solar system? Share your thoughts in the comments below. I read them all and I'm fascinated to see what this community thinks about one of the biggest astronomical mysteries of 2026. The implications of these discoveries extend far beyond astronomy. Understanding the true nature of our heliosphere is crucial for the future of human space exploration. The heliosphere shields our solar system from 70% of incoming galactic cosmic rays, high-energy particles that pose significant radiation hazards to astronauts and electronic equipment. If the heliosphere is more irregular than we thought, with weak points, where cosmic rays can penetrate more easily, this could dramatically change how we plan long-duration missions to Mars and beyond. Future spacecraft might need to plot courses that avoid these high-radiation regions. These findings also impact our search for habitable exoplanets. A planet's habitability isn't just determined by its distance from its star, it's also affected by how well the star's astrosphere protects it from cosmic radiation. If astrospheres are commonly distorted by interstellar structures, we may need to revise our criteria for potentially habitable worlds. There are even implications for Earth's climate history. Our solar system completes an orbit through the galaxy every 230 million years, encountering different interstellar environments. If these environments can dramatically affect our heliosphere, they might also influence Earth's cosmic ray exposure over geological timescales, potentially affecting cloud formation and climate patterns. By understanding these complex interactions between our star and interstellar space, we're gaining insight into the delicate balance of forces that make our cosmic neighborhood hospitable to life. The good news is that this mystery won't remain unsolved for long. New Horizons will continue collecting data until at least 2028, when its radioisotope power system will no longer generate enough electricity to operate its instruments. Every day brings new data that helps refine our models. NASA's Interstellar probe mission, scheduled for launch in 2030, has been specifically designed to investigate these heliosphere anomalies. This ambitious mission will travel 3 times faster than New Horizons, reaching the Heliopause in just 15 years and continuing far beyond to provide direct measurements of the structures causing these distortions. Meanwhile, the Interstellar Mapping and Acceleration Probe, IMAP, launched in 2025, is already providing complementary data from its position near Earth, helping scientists create more comprehensive models of the heliosphere structure. With each new mission and observation, we're getting closer to understanding the true nature of our solar system's boundary and its place in the galactic environment. But this isn't the only cosmic boundary challenging our understanding. In upcoming videos, we'll explore the mysterious, great attractor, pulling our galaxy through space, the unexpected, cold spot, in the cosmic microwave background that might indicate a neighboring universe, and the strange, Fermi bubbles, extending above and below our galactic center. Each of these boundaries holds clues to the larger structure of our universe and our place within it. Subscribe now so you don't miss these cosmic explorations. Thank you for joining me on this journey to the edge of our solar system and beyond. The universe continues to surprise us, reminding us that there's always more to discover, even in our cosmic backyard. Remember, in science, the most exciting phrase isn't "Eureka," but "that's strange." Until next time, keep looking up.